On the 22nd of September 2020, Tesla had their annual meeting of stockholders and Battery Day. During the session, Tesla CEO Elon Musk and SVP for Powertrain and Energy Engineering at Tesla, Drew Baglino, both made a series of very crucial announcements about the future of the company. One of those announcements was the new battery cell that they are developing that would change the electric vehicle industry forever. In fact, this battery is so important that it's going to make electric vehicles from Tesla as cheap as $25,000. The audience of Cars cheered with their horns as they welcomed the new car that would dethrone them. It felt like something from Cars. But how come a single innovation on their car batteries is going to change the cost of the entire vehicle as well as its performance? Well, in this video, we're going to see why the 4680 tabless battery is such a game changer, and what's a better place to start than at the beginning. But first, welcome back to our channel. If you haven't already, make sure you hit the subscribe button and ring that bell so you're notified every time we upload a new video. Great. Now, where were we? Ah yes, at the beginning. You see, electric vehicles, or EVs, have always existed. In fact, in the late 19th century and early 20th century, there were just as many as internal combustion engine cars, or ICEs, being driven around. However, they faced several issues concerning the range and charging. Eventually, with the advent of the electrical igniting device for gas engines, coupled with the mass production of ICE vehicles using Henry Ford's novel assembly line, EVs would see a massive decline in production and use. ICEs hit higher speeds, had more range, and did not require frequent charging due to a higher specific energy, or energy density. This energy density is the amount of energy that a unit of mass or volume in a particular system will produce. The new 4680 batteries will produce 5 times more energy than its predecessor, the 2170. You see, the names of these batteries are actually their dimensions. The 2170 has a 21mm diameter and a 70mm length, while the 4680 has a 46mm diameter and an 80mm length. So, of course, the 4680 has more energy with its bigger dimensions. But it's not just about size, it's about what you can do with it. You see, both ICEs and EVs make use of batteries. However, while ICEs make use of their batteries to ignite the car engine and run things like the music, EVs make use of their batteries to run everything, including the movement of the vehicle itself. This has required a lot of technological ingenuity over the years. Let us take a look at a battery cell. A typical battery cell makes use of electrodes and an electrolyte. A battery has 2 electrodes, the positive terminal, called the cathode, and the negative terminal, called the anode. The electrodes react with the electrolyte to give off some electrons through the anode. These electrons are then channeled through a circuit till they get back to the cell through the electron-deficient cathode. You see, what we do with batteries is to move electrons from one point to another while making the electrons do work for us as they travel. In ICE vehicles, the electric current passes through the alternator to start the engine. In electric vehicles, it passes through an induction motor. The battery is more powerful depending on the mass of the battery's components, the type of connection, and the type of anode and cathode material being used. The 4680 is obviously bigger, so there's that. As for the connection, battery cells can be connected in either a parallel or a series. Connecting batteries in parallel increases the current or capacity, while connecting the batteries in series increases the voltage. The Tesla Model 3, for example, makes use of the 2170 battery cell, which has a 3.65 voltage and a capacity of 4,000 mAh. The Model 3 is fitted with over 4,000 of these cells using both parallel and series connections to increase both the overall voltage and capacity. This results in an energy density of 150 kilowatt-hours per kilogram and a range of 310 miles, which is pretty great. This is standard Tesla practice, so we can expect to see the same connections for cars with the tabless batteries. When it comes to the anode and cathode materials, the 4680 uses lithium-based compounds for its cathode, while the anode is going to be silicon instead of the graphite that is more common in other Tesla batteries. The company decided to make the choice to remove cobalt from its batteries as its production has some questionable processes. However, these new additions and subtractions in the battery's constituents actually reduce the cost for making the battery while being more efficient. Subsequently, the dollar per kilowatt-hour for 4680 is lower than that for the 2170 battery. Another cost-reducing step is the implementation of a dry coating process for the cathodes instead of the wet process. The dry process would not require the amount of solvent and machinery used in the wet process, thereby cutting down factory space drastically, while making the process more environmentally friendly while eliminating wastewater. But perhaps the most important addition is the tabless feature, or should I say the most important subtraction, as Tesla has engineered their batteries to move from having a tab to, well, not having a tab. The tab is a metallic strip placed on the anode and cathode to direct the flow of electrons. With one strip each on an electrode, the electrodes have to travel along distance from one strip to another. This long distance creates resistance and power loss, which in turn causes overheating, leading to Tesla incorporating glycol casings in the battery packs to cool down the system. But let us look at the tabless design. First off, let's start by establishing the fact that the 4680 is not tabless. Before the anode, cathode, and separator are rolled into a sheet, they are actually fitted with several of these tabs, but in such a manner that the tabs overlap. When the entire thing is rolled up into the jelly roll, it looks like this. The result is that the electrons have a far shorter distance to cover. There is less resistance and a drastic reduction in power loss as well. This of course solves the overheating problem and will make charging the battery much faster. It is expected to get a full charge within 10 minutes using a supercharger, and since it has 5 times more energy, 6 times more power, and will increase range by 16%, we can expect to be seeing way less charging times than we're seeing in any EVs today. And it's all because of the tabless, rather the tab-full, design. However, Tesla is also taking advantage of the size of these batteries. Size is not all that matters, but bigger is usually better, you know? And Mr. Musk knows this full well. That is why, moving forward, they've decided to make use of the batteries for the structure of the cars as well. Instead of being inside cases at the bottom of the bottom of the car itself is the case for the battery packs. This helps reduce the parts involved in the car, as Tesla plans to implement a gigacasting machine to build the single biggest cast for an automobile to implement these designs. So let's look at the overall effect of the 4680 tabless Tesla battery. First, it has more energy, power, and range. Meanwhile, the production process, which will be done by Tesla themselves, is cheaper, requires less factory space, and is more eco-friendly. The battery also adds to the integrity of the car, as the new structure plus the low center of gravity of Tesla cars make their cars nigh on impossible to topple over. All this and more with a lower dollar per kilowatt hour. This makes it clear why Tesla can talk about a $25,000 vehicle with these batteries. See, the battery packs constitute about a quarter of the car's weight and cost, so a reduction in the cost of the battery will also mean a reduction in the price of the car, coupled with other innovations Tesla will incorporate into their cars. Musk has stated that a full integration of this battery in cheaper EVs at a good scale will be available in 3 years from now. That was almost a year ago, and when a $25,000 electric vehicle becomes available, there will be almost no need for people to buy ICE vehicles, since in addition to the fact that they are cheaper to have, all of the other constraints we talked of earlier will then be eliminated. Range will increase dramatically, charging will be easier, faster, and last longer, and EVs will cost just as much as ICEs, reversing the impact of Henry Ford's assembly line innovation centuries ago. Electric vehicles will be the most used cars, carbon emissions will be drastically reduced, and psychopaths will have no excuse for having jumper cables in their vehicle. And it'll all be because of this magnificent innovation, the tabless 4680 battery. But what do you think? Is the tabless 4680 battery on the same level as the invention of the assembly line? How much effect do you think it will have on society? Let us know in the comments below. And if you enjoyed this video, make sure to give it a like, and check out other awesome ones on the Simply Tech channel. Thanks for watching, and we'll see you next time.